Determinant of a matrix means, like we have seen the matrix. Matrix means it is of the form like A will be there, Aij will be their entries. Okay, it is an arrangement. Okay, determinant of the matrix means the value of the matrix, that a unique number to represent the matrix. Okay, switch on the video, man. So this determinant of A will denote it like determinant of A. This like we denote, or DET of A like will denote. Okay, so a unique number allotted to this given one, that is value of the matrix, is called determinant. So when you notice this, matrix means we'll put like this bracket, like the closed bracket, and determinant means we'll put a vertical bars. Okay, sometimes it may be referred as D of A also, based on the author what we are learning with. Okay, now how to find the determinant of a 2 by 2 matrix? Determinant of 2 by 2. Yes, it is not a function, it is a value of a matrix, a unique number. Okay, so let us take this 2 by 2 matrix, like A, B, C, D. It is 2 by 2, and keep in mind that only for square matrix only we can able to take the determinant, and not for the any other type. Okay, so for this square matrix, 2 by 2 matrix, the determinant value is, the determinant of A is nothing but determinant of, like you observe the difference, like I put some 2 vertical bars. Okay, now product of these two elements, that AD minus product of these two elements, CD. This is what the value of the matrix. For example, you take 2, 3, 7, 2. Like this I am taking one matrix. Okay, now this is the matrix A. Determinant of A means the determinant of this 2 by 2 matrix. Like I removed that square bracket and I kept 2 vertical bars. So the value is 4. 2 2s are 4 minus 7 3s are 21. So minus 17 is our answer. So this minus 7 is the value of the determinant of the matrix. Okay, any doubts on this? Okay, and a few more points to be noted. So matrix, that's all. A matrix is an matrix is an arrangement, array of numbers. Okay, and determinant is a value. Now minor of an element. Minor of an element of a square matrix. Let us say the matrix is of order n by n, that is a square matrix, right? Okay, and its minor can be of order 1 less than this or 2 less than this, like any other minor you can take. So minor can be of order, minor is the determinant of order less than n. It can be n minus 1 by n minus 1, or it can be n minus 2 by n minus 2, like it may be. Okay, like we'll see only for 3 by 3 matrix. So let us take this 3 by 3 matrix, that is A1 B1 C1, A2 B2 C2, A3 B3 C3, like I am taking one 3 by 3 matrix. So here each element has its minor. Okay, now listen carefully. This minor of A1 is nothing but leaving the row and column where this A1 belongs. Okay, we should be leaving this row and this column. Remaining one 2 by 2 matrix will be there. So the determinant of that remaining 2 by 2 matrix, B2 C2 B3, C3. That is what we call it as minor. Okay. And minor of B1. Guess what minor of B1? Leaving the row and the column where this B1 belongs. Okay, are you listening? Just leave the row and column. That's all. A2, C2, A3, C3. Okay, shall I erase this other side? Okay, what is minor of C1? So likewise, how many minors we can write? Like leaving the C1 row and the C1 column. A2, B2, determinant of A2, B2 and A3, B3. Okay, like this for all the 9 elements we can write minor, leaving the row and column of the corresponding element. Okay, these minors are denoted by Mij. Mij means this is A11 elements minor, so that is M11. Okay, this is B1's minor, right? B1 is which place? M12, and this is M13. Okay, that is what minor is about. And cofactor, yes. This determinant again we have to calculate. Only 3 by 3, not only 3 by 3. You can take 4 by 4 also. 4 by 4 means a good question. See, 3 by 3 matrix will come. That's what I said. Order can be less than 1. One less than that given order. Okay. 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 And then, see, if they say simply minor means order will be 1 less than the given order. Okay, for this we can take 1 by 1 also minor. Okay, like any minor you can take. This is 1 by 1 minor, this one can be 1 by 1 minor. Okay, so if I take this 4 by 4 matrix, this A1, B1, C1, D1 and A2, B2, D2, C2, A3, B3, C3, D3, A4, B4, C4, D4 like we are taking means the minor of A1 will be what? Minor of A1 will be this 3 by 3 matrix. Okay, like minor of this element. Okay, but apart from this we can take any 2 by 2 minor. It does not need to correspond to any element. Like in upcoming sections we'll be seeing, like finding the rank by that kind of situation and all. We'll take one like less than the order that minor. 3 by 3 minor you can take, or 4 by 4 minor, that is different. Simple man. 2 by 2 means any two we can check. Okay, this and all comes later, man. Like while finding rank, that kind of situation we'll be taking. First we'll take 3 by 3 and then 2 by 2, 1 by 1, like that we'll take. Okay, but generally minor means, now only we are learning the definition. Generally minor means corresponding to an element, leaving that row and the column, we'll calculate it. That's all. Okay. Okay. So it will be of order one less than the given order. Next, cofactor of an element. Cofactor of an element of a square matrix, which is nothing but simply like this minor we are denoting like M1 Mij, right? Cofactor is denoted by Aij, denoted by this capital Aij. Okay, so capital Aij means So I'll write the formula that capital Aij is equal to minus 1 power I plus j mij. That means calculating the value of the minor and multiplying with a negative sign based on the sum of the subscripts. Okay, this might get confused. See, we'll calculate A11. A11 is what? Minus 1 power 1 plus 1 into M11. Okay, so minus 1 power 1 plus 1 is what? 2. Minus 1 power 2, it is plus 1. So we'll get simply M11. Okay, now A12 you take. That minor is minus 1 power 1 plus 2 into M12. Minus 1 power 1 plus 2, which is minus 1 power 3. Odd power. We'll get negative. Okay. Okay. And A13, guess what? Like minus 1 power 1 plus 3 M13, it will be positive. Okay, simply see, for this positive, negative, positive, and for this negative, positive, negative, positive, negative, positive, I am just putting alternatively. Simply if you take, this is what placement, like 1 comma 2. Okay, sorry, A21, right? Listen, A21, so 2 plus 1 will be odd, so that will be what? Negative. That is what? Okay, that is what? Cofactor. So minor means taking a 2 by 2 minor, leaving that row and column where that element belongs, and cofactor means multiplying this minus 1 power I plus j. Okay, that value also, this only, this like only it will come, like alternatively positive, negative. Okay, so let us this one. Okay, and this cofactor matrix can be written like, this cofactor matrix can be written like capital A1, A2, A3, B1, B2, B3, C1, C2, C2. Okay, so that means what? Minor of, cofactor of A1, this A11's cofactor is A1, A12's cofactor is A2, like that. I wrote that A1, A2, A3 like that, no, that matrix. Okay, that is the idea. Yes, sir. Yes. See, simply if we take A2 means what? A2 means what? This is what? Minus 1 power 2 plus 1. Not. See, this is M21. Okay. M21 means what? This is odd, minus of M21. What is the value of M21? Not that cofactor, man. Like, this is the cofactor of first element. This is cofactor of second element. I wrote the cofactor matrix. That's all. Cofactor means that is a value, right? Cofactor means it is a value. It is not a matrix. Determinant means value only, right? This is M11 and all, what? One value will come. Okay. We'll see with an example. See, the other day we worked out some examples, right? Like the orthogonal. Actually, that question was wrong. I checked. Okay, we'll solve some questions, man, based on this. And then we'll move on to the next one. Okay. So, minor cofactor, you understood, right? Okay, I'll explain to you with the question. Now, take the exercise 3.4. So, let us see everything. Okay. So, this exercise 2.4, first question. Find the minors of minus 1 and 3 in the matrix given 2, minus 1, 4, 0, minus 2, 5, minus 3, 1, 3. So, we should find minors. Minor of minus 1. Where is minus 1 you see in the matrix? this place. Okay, this minor of -1 is what? M12 we should find. Okay, M12 means what? Leaving the row and column where this -1 belongs, writing the remaining elements, the determinant of remaining elements, that is 0, 5, -3, 3. Alright. Now how to take the determinant value of this 2 by 2? Remember, in this direction we should multiply 3 into 0, 0, minus, see this minus comes in this one itself. Okay, it is not 18, 0 into 3, 0, right? And this one -3 into 5, which is -15. Okay, so minus of minus plus 15, that is the value of minor. And then minor of 3 is what? Yes, minor of 3 means leaving the row and the column where this 3 belongs. So let's scribble so much. Then what will be the minor, 2 by 2 minor of this 3? Minor of 2 minus 1, 0, minus 2. Then multiply. Then we'll get -4 in this direction. -4 minus 0. Answer is -4. Okay. 0 into -1, like -1 you kept again, is it? Is it somewhat -3 something? That is 0. Okay. So that is the value of minor. Yes man, 0 into -1, how much man? You kept -1. Okay, the second one. Find the cofactor of the elements. Find the cofactors of 2 and -5 in the matrix -1, 0, 5, 1, 2, -2, -4, -5, 3. Okay. Now, see, cofactor means what? Where is 2? First we locate 2. So here it is 2. Okay, it is in the place A22. Okay, so we'll be finding the cofactor A22. What is the formula for cofactor? Remember, Aij means -1 power I plus j into Mij. So this is what cofactor of 2. So this one is -1 power 4. What is M22? Minor of this element. Leaving this row and column, we'll be getting -1, 5, -4, 3. Okay, wait. This is positive. So we'll put to +1 into -1 into 3. We'll get minus of minus. 4 5s are 20. That too -20. Is it? So minus of minus will become plus. -3 plus 20 will get 17. Okay. And what about cofactor of -5? We get -5 in here. So instead of leaving this row, we should be leaving this row. This is at which place? A32. A32 is -1 power 3 plus 2 M32. So this is minus, like -1 power 5, which is minus, and leaving the row and the column, we should be writing what? -1, 5, and 1, -2. Now multiply. So let us the other side. So this is minus of -1 into -2, which is +2, minus 1 5s are 5. So we'll get minus of -3. Answer is 3. Okay. Can you able to say the answer for the next one? Like product of cofactors of 3 and -2 in the matrix 1, 0, -2, 3, -1, 2, 4, 5, 6. Okay. So for 3, see this is simple man, positive, negative, positive, negative, positive, negative, positive, negative, positive. So minus this one what? Cofactor minor of 3. Minor of 3 means leaving this row and column. Then this is 0 minus 2. Like 0 into 6 is 0 minus of minus 10. So we'll be getting plus 10. And for minus 2, here we have minus 2. That position is positive. So positive of leaving that row and column. I mean this row and this column leaving. 3 5s are. See this one all for this cofactor sign only simply mentioned. Does not belong to this number sign. Don't get confused. Okay. I am doing it in a shortcut, quick way. Okay. 3 5s are 15 minus of minus 4. So it will be 19. Yes, minus 10. This minus I left, right? Then the product is what? Minus 19. That is it. Alright. Have you understood the difference between minor and cofactor? Okay. So let us everything. Okay. Then we'll finish the determinants and then we'll work out some questions of this. Okay. Now determinant value of a square matrix. So that is everything. Yes, it is. Okay. Determinant value of a square matrix means 3 by 3. 2 by 2 we have already seen. Determinant of 3 by 3 matrix. Okay. Okay. Now determinant of 3 by 3 matrix means get a 3 by 3 matrix like we said already. This is A1, B1, C1, A2, B2, C2, A3, B3, C3. So determinant of this matrix means which is nothing but this first element into its cofactor plus the second element into its cofactor, this third element into its cofactor. Like we can take any row or column. Okay. Okay. Don't get confused. We have seen what is minor, what is cofactor. Now determinant value of a 3 by 3 matrix means what? This is the concept actually. Determinant value means the first element with multiplied with the cofactor of the first element plus second element multiplied with the cofactor of the second element, third element multiplied with the cofactor of third element. Even for 2 by 2 also we have done the same thing, but you know or not, let me see, wait I'll say. For this 2 by 2 matrix like A, B, C, D you will take. What is minor of A, you know? Say what is minor of A? Minor of A in this matrix. Leaving this row and column, this is D. Okay. So first element into minor of, cofactor of this. This is a 2 place, right? So positive, negative, negative, positive. Okay. So A into D plus what is second element? B. So which one is the cofactor of this one? Minus C. Okay, leaving this row and column of B, this one cofactor I am saying, not minor. Okay, so that is what we get AD minus BC. That is the determinant value of the 2 by 2 matrix. Concept wise same. Element should be multiplied with its corresponding cofactor. Okay, like this should be done for the only first column. Even for the first row also we can do, or first column also we can do, or first row, but any one row or one column you can take. Whatever the column or row you take, the value must be the same. Value will be the same. It's not must be. Value will be the same. Okay. So first to get understanding, this is the concept you understood, right? Like 3 by 3 matrix means element multiplied with its cofactor. We'll see one example and then we'll proceed with the other things and all. The other confusing things and all we'll see. determinant of the 3 by 3 matrix only value I written. Okay. See, minor is different, determinant is different. Okay. Like determinant is this one, like determinant of A, B, C, D, like we take. But minor means leaving the row and the column, remaining things you are taking, that is minor. With that remaining sub matrix, like you can call, for that we will take determinant means that is called minor. Okay. Now we'll take some example. See, let us take this example. The matrix A 1 0 minus 2 3 minus 1 2 4 5 6. This is the given matrix, right? For this you should find the determinant value. So what I said, determinant means what? It is a sum of the product of first element into, first element is 1 into cofactor of this 1 is what? Minus 1 2 5 6, right? And then again I should put plus, but this is the second element, right? Second element means cofactor will be what? Negative 0 into, why I kept negative here? Because this is 1 2 place. Okay, that minus I power 1 plus 2, sorry, minus 1 power 1 plus 2, that one. So minor of this 0 is what? It doesn't matter, but 0 means 0 only, but we should write. So this is 3 2 4 6. Okay, and plus, because this place is plus and the number is minus 2 into determinant of this, that is 3. Let me write here, plus plus of minus 2 into, yes, that's what I am saying. For first row I am writing first. Okay, then the same concept will apply for the other row, other columns. We'll check the answer is correct or not. Okay, concept wise now only I am saying what is determinant. So we should take any one row. I have taken the first row. For the first row I am taking the first element multiplied with its cofactor, plus the second element multiplied with its cofactor, plus the third element, that is minus 2, multiplied with its cofactor. Cofactor is positive here, so we'll put simply the minor. Now what is the value, you know? So 1 into determinant value minus 6, like minus 6 minus 10, minus 0 into, we don't need to multiply as this is very first question I am working on. So 3 6 are 18 minus 4 2s are 8, and then minus 2 into, because plus into minus, which is minus, 3 5s are 15 minus 4 1s are minus 4. Got it? So minus 16, this one will become 0, minus 2 into 19. Okay, so minus 16 and minus 2 into 19 is what? Minus 38. So how much it is? Minus 54. That is the determinant value. Okay, any doubts in this? Okay, now this is along any one row or one column is enough. I am taking it along the first row, row 1. So this is R1. Okay, like I am taking, like along R2 we will take. Along R2 means the determinant value is still the same, should come like same. First element 3 into minor of this 3 is what? Sorry, not minor, cofactor of this 3 is what? Like leaving the row and the column of 3 belongs, this row and this column will be left. So 0 minus 2, 0 minus 2, 5 6. So this will become negative, because this cofactor sign is what? Negative. This is 2 ones place, right? Minus 1 power 2 plus 1. For that only I said what? Simply put plus minus plus minus plus minus plus minus plus. Okay, so now plus of minus 1 into the minor of the minus 1. So leaving the row and the column where this minus 1 belongs, then we'll get 1 minus 2, 4 6. and then last element again minus, because that cofactor sign will be minus, because that is which place? 2 3's place. Okay, so minus 2 into the minor of that 2. Minor of this 2 is what? Leaving the row and the column of where this 2 belongs. Where this 2 belongs, like leaving this row and this column. 1045. Any doubts on this? See, simply I have written an element multiplied with its cofactor. That's all. Okay, now let me erase it here. Now we will start calculating these things. So what we will get is minus 3 into 0 minus of minus 10, and then minus 1 into 6 minus of minus 8. Okay, and then minus 2 into 1 5s are 5 minus 4 into 0 0. So this is minus 3 into 10. This is minus of 6 plus 8, and this is minus 2 into 5. So we'll get minus 30 minus 14 minus 10. How much is the answer? Minus 54. Okay, so we can take along any row or any column. You can even take the first column, still you get the same answer. But traditionally when they ask for determinant, we'll take only first row. That's enough. Okay, okay, so that is how this determinant works. Shall I erase everything? Okay, now I'll give you one question. You try finding the determinant, like along the first row and along the first column, whether both comes like same or not, you check it. Easy one. Let the matrix A, suppose the name is not given, means we should name it. We should name the matrix. Okay, find the determinant value. How long will you do? Easy question. First element will be 0. Next this is minus 1. Row and column left 0 minus 1. Minus into minus 1 plus 1. Then 1. Answer 2. See, the determinant of A is 0 into the minor of this 0. Okay, so 0 minus 1. Okay, and minus 1 into the cofactor of this one. Why I kept to minus 1 means this place sign is negative, the cofactor sign is negative, that's why. So leaving the row and the column, 1 0 is 0 minus 1. Okay, plus last one, this 1 into what? Leaving that row and that column, 1 1s are 1 minus 0. So we'll bet 0 minus of minus 1 is what? Plus 1 plus 1, answer is 2. Then where you did the mistake? Check. This is along R1 I take. What? Second one, right? You took this entire thing as 0, is it? You took this entire second term as 0. Yes, that's the thing. Okay, this is along the R1. What about along C1? C1 means column 1. See, this is C1, C2, C3. Heard this anywhere? C1, C2, C3 and all. In our school, C1, C2, C3. 9th, 10th, 11th, see much. Okay, along C1 you take. What are all the signs? This is positive, negative, positive, negative, positive, negative. I mean cofactor sign I am putting directly. Okay, now along the C1 we'll take man. Answer. I told you to take along the C1. We took along R1, I wrote the answer. C1 you did completely? Yes, quickly, do it. Now, for this matrix, man, find the determinant of this matrix. Cos alpha plus I sin beta, I sin alpha. Just a minute. The matrix A is cos alpha plus I sin alpha, cos beta plus I sin beta, and sin beta plus I cos beta, sin alpha plus I cos alpha. Okay. Now we should find the determinant of this matrix. First of all, is this square matrix? Like rectangle manner it is coming. Square matrix, yes, we have 4 elements. 1, 2, 3, 4 elements. So what we do? As usual, determinant of A is what? We'll remove the square bracket and we'll write this vertical bars. Cos alpha plus I sin alpha is AD minus BC. And this is cos beta plus I sin beta, and this is sin beta plus I cos beta, and this is sin alpha plus I cos alpha. Simply multiply AD minus BC. Okay, so we'll get these two elements should be multiplied. Cos alpha plus I sin alpha into sin alpha plus I cos alpha. Both are different, they are not same things, and minus these two elements. So sin beta plus I cos beta into cos beta plus I sin beta. Now as usual that algebraic multiplication, polynomial multiplication we can do. So this cos alpha into sin alpha is cos alpha sin alpha, and this is plus I cos square alpha. Next this one plus I sin square alpha, and these two plus I square sin alpha cos alpha. Same thing will come but with a negative. So here sin beta cos beta, these two multiplied means again sin beta into I sin beta plus I sin square beta, and plus this one I cos square beta, and this one I square cos beta sin beta. Okay, so this one cos alpha sin alpha will be as it is, we don't get to simplify this, and this is these two terms will take is common. If you take is common means cos square alpha plus sin square alpha, and plus I square will be negative. I square is minus 1, right? So minus sin alpha cos alpha minus, here also the same thing, what it is, yes man, 0 is the answer. Here also sin beta cos beta will come, and this is plus I into sin square beta plus cos square beta. Same thing with the beta will come, then minus cos beta sin beta. So these two things gets cancelled, these two things gets cancelled, this value is 1, we'll get I minus I, we'll get 0 things. Okay, Singular matrix means we find the determinant, right? Suppose if we got determinant of the matrix is 0, then we say the matrix A is singular. Okay, very easy. And based on that, few more properties also there, like suppose this determinant is not equal to 0, determinant 1, then it is non-singular, that's all. Okay, also if A is singular, if A is singular, then this A transpose is also singular. Okay, and if A and B are similar, non-singular matrix, A and B are non-singular, then their product also non-singular. Does not mean that they are equal. Okay, then AB is also non-singular. Okay, what about if A and B are singular? Product also will be singular. So determinant of A and B. I think we have one more property of this determinant, like determinant of AB is equal to determinant of A into determinant of B. Like it came somewhere. No. Okay, we'll see. We have one more topic called properties of determinant. While seeing that, I'll say you those things. Okay, like if A and B are two square matrices of same order, then determinant of AB is equal to determinant of A into determinant of B. Okay, like you multiply the matrix, get the determinant, that value will be equal to product of their individual determinants. If A and B are singular, like any one of A and B is singular also, we'll get determinant of AB is equal to 0. Okay, now look into the next question, that if the matrix is singular, the seventh one, if the matrix A 8 minus 6 minus 2, sorry 8 minus 6 2 and minus 6 7 minus 4 and 2 minus 4 lambda, this is singular they say, then we should find the lambda. There is one easy method to find the lambda, you know. See, here it is, we found. Okay, we should find the value of the lambda. How to find the value of lambda? It is said that the matrix is singular, that means this determinant of A will be 0. So what is determinant of A? We can take along any row or any column. I am taking along the first row. So 8 into 7 lambda minus 4 4s are 16, that plus 16. Okay, see, while putting the second element, we should be really very careful. There is a lot of chance you can miss here. Okay, and this one minus of minus 6 will become plus 6, because that place is what? Remember, this is plus minus plus cofactor signs. Okay, so minus of minus 6 means plus 6. So now this row and this column leave it, then minus 6 lambda plus 8. Why plus 8? Minus of minus 8 will become plus 8. Once you habituated, there is a lot of chance that you may commit mistakes in there, so you should be really careful while doing the determinant. Okay, then that last element 2, that row, that column leave it, 6 4s are 24 plus 24 minus 14. That value is equal to 0. Okay, already we know it is 0. So this is 8 7s are 56 lambda minus this is 80 48 to 128. Okay, and plus 6 6 are 36 minus 36 lambda plus 48, and this is also plus not 48, 24 minus 14, which is 10 plus 20 equal to 0. Simply calculate. 56 minus 36 will be 20 lambda, and this is 20 plus 48 68. 68 minus 128, which is minus 60. So we'll get lambda value is what? 3. That's all. The same way, one more question also there, like the 8th one. If that particular matrix is singular, then we should find the value of theta. Okay, it's very easy. So that is our thing. Okay, how fast you are writing, man? Like now only I am finishing, but you completed. That's strange. Before me you completed, is it? Good. Okay, now look into the 8th question. See, the matrix A is cos theta sin theta 0 and sin theta cos theta 0 0 0 1. Very simple. What clever people will do means, they will not take determinant, like this is singular means, if this is singular, find theta they say. Okay, what clever people will do means, they will not take blindly with the first row. Okay, if you take with the last row, it is easy. First two elements is 0. So we don't need to find the cofactor. Simply 0 into anything 0. Then this one we can take. But we should be really careful with the sign. We can even do with the last row or last column, whatever. So this is cofactor sign when putting plus minus plus, this is minus plus minus, this is plus minus plus, right? Now this last row, now along R3 I am taking. R3 means row 3. So this is first one is what? 0 plus 1 into that minor of this element. Cos theta sin theta. This is sin theta cos theta. Okay. So this is, when you multiply cos square theta minus sin square theta will come. So that value is equal to 0. Okay. So there is a formula. Cos square theta minus sin square theta means, what is the formula, you know? Trigonometric formula. No, it is cos 2 theta. We are saying all the things. Cos 2 theta is equal to 0. So for cos, which value will get 0? Cos pi by 2. Cos 2 theta is equal to cos pi by 2. So when you equate the angles, 2 theta is equal to pi by 2, theta is equal to pi by 4. But you said pi by 2 before, right? Yes. Don't come to any conclusion before solving the question. Okay, it's always better to solve. Okay, that is it. Still one more topic is there, like properties of determinant, that we will continue with the next session. Okay, do you have any doubts in this determinants of 2 by 2, 3 by 3 and all? Okay, if possible, that first half of the exercise try to finish. Okay, first half means the first 2 questions then. That's all. Okay, that's enough for the day.